Pima Indians diabetes. Problem statement. The objective of the dataset is to diagnostically predict whether or not a patient has diabetes based on certain diagnostic measurements, including in the dataset. All patients are females of at least 21 years of age and of Pima Indian heritage. The dataset consists of several medical predictor variables and one target variable, outcome. Predictor variables include the number of pregnancies the patients have had, their BMI, insulin level, age, and so on. Let us import the required libraries, including Pandas and Model Selection from sklearn. Also, we will import AdaBoost classifier from sklearn.ensemble to further optimize our model. Import Pandas, import sklearn import model _selection. From sklearn.ensemble, import AdaBoost classifier. Now load the dataset with a Pandas data frame. Extract the values from the columns in the form of an array. Set the random seed value as 7 and number of trees as 30. We will build classifiers using AdaBoost and XGBoost. Let's create the AdaBoost model using scikit-learn. AdaBoost uses decision tree classifier as the default classifier. Pass the model within the cross-validation score function to evaluate the results using the cross-validation technique. Construct the model now by splitting the trained test indices into 10 consecutive folds. Again, evaluate the model such that each fold gets used once as a validation while the remaining 9 folds form the training set. Print the results. AdaBoost gives an accuracy of 76%. Similarly, we apply the XGBoost algorithm. Import the respective modules, namely SVM and XGB classifier. From sklearn, import SVM. From XGBoost, import XGB classifier. Initialize the XGB classifier under the name CLF. Set the seed value as 7 and number of trees as 30. Construct the XGB classifier using the k-folds technique such that number of folds equals 10. Evaluate the model using the cross-validation score, similar to the way we did for AdaBoost classifier. Again, the accuracy is around 77%. We have shown only 2 classifiers. You can use different classifiers and compare the results. Also, check results after applying 10-fold cross-validation. Great, we have seen how to apply boosting algorithms to classification. Let's quickly recap the steps we covered. 1. Build models using AdaBoost and XGBoost. 2. Compare the accuracy of classifiers. Model selection. When do you need to evaluate the model performance? Models can be evaluated based on measures of performance. Model evaluation aims to estimate the generalization accuracy of a model on future data, that is, unseen, out-of-sample data. So model evaluation techniques are used to evaluate the model's performance when there is a chance of evaluating new data that is unseen or out of sample. Let's now look at how to access model performance. Train, test, split, or cross-validation split are the techniques used to evaluate the model performance. Train, test, split divides the training data set into two sets and uses the first training set to train the model and tests the model using the second set. Cross-validation split splits the data set in two sets, namely train and test, and then calculates the accuracy of each set and finds the average of the results. Let's look at how train-test-split works. So we have a given data sets that we need to split into training data and testing data. Split the data randomly using negative and positive symbol. Now, when you have training data randomly selected from the given data set, the remaining data falls under the test data. Move this data into the hypothesis space. Make sure that your test set meets the two subsequent conditions given. The test set must be large enough to yield statistically meaningful results. The test set must have different characteristics than the training set. Now verify the result by matching the train data with the test data. Now test the training data individually with respect to the test data present in the hypothesis space. Wherever the data that has the same symbol matches, it provides accurate result. Prediction given here is 9/13, which shows the matching prediction. Common splitting strategies. So let's understand what percentage of data should be used for training and for testing. So we can use either of the two common splitting strategies to split the data. K-fold cross-validation or leave one out. Let's first understand how K-fold cross-validation works. The procedure contains a single parameter referred to as K and points to the number of groups that a given data sample is to be split into. As such, the procedure is usually referred to as K-fold cross-validation. When a particular value for K is chosen, it's going to be employed in place of K within the relevancy of the model. So how does the leave one out technique work? This approach leaves one data point out of the training data. That is, if there are n data points in the original sample, then n1 samples are used to train the model, and 1 point is used as the validation set. All the combinations are created in this way. The original sample can be separated and the error is averaged for all trials in order to provide overall effectiveness. Now let's understand the difference between train, test, split, and cross-validation. Advantages of cross-validation. 1. It is a better estimator of out-of-sample accuracy. 2. It provides a more efficient use of data since each data is used for training and testing. Advantages of test-train split. 1. Runs K times faster than K-fold. 2. Simpler than K-fold, so it would be easier to analyze the testing errors.